Under the Mobil Serv offer, this video is a piece of the bearing on-the-job training curriculum that will enable you to convert customer needs and opportunities around bearing reliability into improvements in safety, environmental impacts, and productivity. The video is the first part of the OJT for bearing inspections. After viewing it, you should job shadow another competent person completing a bearing inspection and then have the competent person observe and coach you as you complete an inspection. The OJT Participants Guide provides an effective way to guide the trainer and trainee through the experiences to gain knowledge and capability. Eric, a field engineer with ExxonMobil, has been working with this plant on a number of Mobil planned engineering service projects. Jeff, his contact at the plant, tells Eric that he'd like them to focus on bearings. The plant has had an increase in dryer bearing replacements over the last few months, and they keep replacing the same bearings.
Bearing after bearing after bearing, prematurely, and I don't know why. We need to figure this out. I need your help.
Eric works with Jeff to understand the impacts of these problems so he can later use this information to show how his findings and recommendations can reduce these impacts and produce value for the customer. They had been mutually planning a bearing removal and inspection. Now this was their opportunity. To help bring solutions and value to his customer, Eric must be an excellent detective and must collect the data needed to help determine the root cause of the increased oil consumption. Before meeting Jeff again for the leakage study, Eric gathered consumption tracking information from the plant so he could identify high users for inspection. He looked at increases in trends to show when new leaks developed. He also calculated the lubricant or hydraulic fluid index, or HFI. You determine this index by dividing the estimated annual oil consumption by the reservoir size. Systems with the highest HFI may prove to be the ones with good potential for investigation. Achieving an HFI under 1 is a good goal. Eric wanted to get a reliable estimate of current consumption rates for each system. Some of these were metered measurements, but in some cases Eric could only get oiler or operator feedback. Eric knew that he must find answers to 3 critical questions. Where to look, by identifying the high consumers as well as potential leakage points. When to look, by identifying when new, significant leaks develop. In addition, he may need to inspect the equipment when it is running as well as when it is shut down to be able to track down the leakage source. When to stop looking, by comparing the sum of leaks identified to the known consumption rate. Eric also went over his safety preparations, like customer site-specific training. Many locations have, at minimum, a visitor orientation video. He also read through the Job Safety Analysis, or JSA, to review the risks and determine the best mitigation steps, including PPE. Then, Eric prepared and reviewed his toolkit for the site visit. Inspection checklist sheets. Ultraviolet UV dye. He will use this in his leakage control studies to show his customer exact points of leakage and to allow him to better estimate leakage quantities. Digital camera and thermographic camera, oil sample kit, and lubricant system schematics or piping diagrams. On the morning of the site visit, Eric and Jeff first review their goals for the visit. Eric goes over his safety plan, and together they review the personal protective equipment they'll need. Hard hat, safety glasses and hearing protection, cut-resistant gloves, visibility vest, and anti-slip steel-toe boots.
I think that should do it. Let's go to it. Let's get it done.
Eric's customer has a dedicated bearing inspection facility, but Eric knows that in some cases you may have to uncover data in different ways, such as by checking metal waste bins and equipment repair shops. Wearing cut-resistant gloves, Eric is looking for failed or removed parts. Eric inspects each part of the disassembled bearing using his bearing inspection worksheet as a guide.
Be careful with the cage here. Yeah, definitely some wear occurred on that one. Erase rotating bearing, right?
He takes a close look at the abnormal wear pattern that Jeff had mentioned. Eric compares the wear on the inner raceways of this double-row spherical bearing.
You've seen it here versus over here.
He looks at the vibration, oil, and thermographic analysis, and also compares the wear patterns to OEM and industry standards. He also takes photos to study later and to include in his engineering report that he will submit to the client. Throughout his inspection, Eric is looking for abnormal wear patterns, discolorations, and foreign particles on the outer ring, outer raceway, cage, rolling elements, inner raceway, inner ring, bearing locking rings, spacers, housings, and shafts. For plain bearings, you would typically inspect the following: the backing, housing, overlay, radial load surfaces, thrust pads, oil grooves, oil holes, flanges, and shaft. In addition, as Eric collects data, he would evaluate these patterns to assess if the wear mode suggests certain failure modes, such as dirt ingression, misassembly, misalignment, insufficient lubrication, overloading, corrosion, poor storage, or bearing defects. Now that he has inspected the removed bearing, Eric needs to gather more facts and correlate other needed field data to help put together the pieces of the puzzle to get to the root cause and best solutions. Eric now goes farther into the plant, and in the basement he inspects the main supply lube reservoir, checking the reservoir temperature and looking at the oil level and sight glass to check color, clarity, and cleanliness. He wants to obtain lube oil system temperatures and those of surrounding components. He checks built-in gauges and monitors. Then he uses his IR gun for confirmation. Then Eric and Jeff inspect the actual bearing and the oil flow meters to the bearing. Again, he uses his IR gun to check the temperature of operating bearings. Then he also uses a thermographic camera attachment to his smartphone to be able to compare the bearing temperature to the surrounding area and other similar bearings in operation. In addition, he checks the bearing surroundings, looking for abnormalities like vibration and contamination ingression points. Eric uses the Mobil EHL Engineering Calculator iPad app to determine proper film thickness to determine the lubricant to be used. He'll add this to his report. In some cases, Eric may inspect a bearing that is still in a machine that may be shut down. Using proper energy isolation, lockout, tagout, and other safety procedures, Eric may use tools like a bore scope to look at some of the same bearing surfaces as he did with the bearing on the inspection table. After his site visit and bearing inspection, Eric will go over his findings, including measurements and photos, to prepare an engineering service report for Jeff and his supervisors. He must take in all the facts and sequence of events to determine the potential root causes. He must work with his customer in cooperation, not only to gather the information, but to form the recommendations that will produce the best value. Eric can demonstrate that his findings and recommendations produce an excellent return on investment and value to his customer. Eric and his sales advisor will use this report to promote our value to other key contacts at this customer. If very well received, this engineering service report could become the foundation of a proof of performance from this customer that could be used to show other customers to convince them that ExxonMobil and its distributors are the right lubricant supplier for them. In addition to helping this customer in this one application, Eric will look to see how he can help the customer apply what they have learned to other similar machines at this facility or across their entire company. By using the standard operating procedure as a guide, as well as the other tools described, Eric can consistently conduct these inspections and deliver outstanding value to his customer.